Okay guys, LLaMA 3.1 family of models has been released finally, and it also consists of the 405 billion model. So we'll be testing this out with our LLM rubric, how actually all these three models perform. I have covered what are the latest updates that we got from this model in my previous video. If you haven't watched that video, I would highly suggest to watch that video and come to this video. So now let's get started. Now I am on the grok.com website. At the top right corner here we can select the models, as you know. Now we'll be selecting the three models that we see over here. In the grok, these three models are named as LLaMA 3.1 405 billion reasoning, 70 billion versatile, and 8 billion instant, complementing the task and the nature of work we can get done from these models. So we'll be starting from the instant model, moving up to the ladder. At the end we'll be checking out the reasoning model. So I'll be splitting this video into many sections. You can skip to the section, have a look at the model that you are interested in. So let's get started with the LLaMA 3.1 8 billion instant model. As you guys know, I'll be testing this model out on 4 main domains, that is reasoning, max, coding, and sentence understanding, which also considers needle in a haystack test. So let's start with our first reasoning question. Okay guys, let's move on to the first question. The question is, a murderer is condemned to death. He must choose between 3 rooms after his sentence has been passed. The first is full of raging fire, the second is full of assassins with their gun loaded, the third is full of lions that haven't eaten in 6 months. Which room should he choose and why? And we know the answer. He should be choosing the third room, which consists of lions that haven't eaten in 6 months, because they are absolutely dead. So let's see if the model is able to reason over this and give us the correct answer. The speed is absolutely awesome, 750 tokens per second, very nice. So let's have a look at the answer. The answer is a classic literal thinking puzzle. The answer is the third room, full of lions that haven't eaten in 6 months, because the lions haven't eaten in 6 months and are likely to be dead, making it the safest option for the condemned man. Very nice. This is a well structured answer and very short answer in my opinion. So let's move on to the level 2 reasoning question and let's see how it performs in that. Let's move on to the level 2 reasoning question. The question is, you are a pilot flying a plane. The plane is empty when you start your journey. At the first airport, 5 passengers board the plane. At the second airport, 10 more passengers board and 3 passengers get off. At the third airport, 7 passengers get off and 6 passengers board. What is the pilot's name? So you can see all this information is not needed. At the start we ask, you are a pilot flying a plane. So it has to answer that it is you who is flying the plane. So the name is yours name, or it should say that my name is Meta and I am flying the plane. So let's see what answer it gives and if it's able to reason this question or not. Here it says a clever question. However, I must point out that the pilot's name is not relevant to the problem. The question seems to be trying to distract me from the actual task, which is to calculate the number of passengers on the plane after each stop. So the number of passengers on the plane after the third stop is 11, but I still don't know the pilot's name. So it actually misunderstood the question in my opinion. Let's give it one more try if it's able to do it or not. Okay, the exact same answer. So I will give this a fail. Although this kind of error I have never seen with any of the other models, but it didn't answer the main question, so it is a fail. So let's move on to the max section and let's see how it performs in that. So this is a very simple max question. So let's see if it's able to do it. It should be able to do it. The answer is 23. Yeah, it absolutely got it. The answer is 23. Going over the steps. So okay, let's move on to the level 2 max question. So this is the level 2 max question. Here the model has to use BODMAS or PEDMAS to solve this. So let's see if it's able to do it or not. Okay, so it says that we will follow the PEDMAS and it gets to the correct answer, that is minus 60.54. This is a pass. So let's move on to the level 3 and the final level for the max question and let's see if it's able to do it or not. Okay, so this is the level 3 max question. In a certain non-leap year, January 1 was a Monday. What day of the week was April 1 of the same year? So this is something which the top of the line models also suffer from. So I have low hopes. Let's see if it's able to do it or not. The answer is Sunday, by the way. Okay, so it says the answer is Monday. It is a fail, and it was expected. It's kind of tough for these small models. So let's move on to the coding section and let's see how it performs. Okay guys, we are in the coding section. I have set up my coding environment, and the first question is write a Python script to output numbers 1 to 100. It should be able to do it. It's pretty easy. So it has given me the correct code, but still let's test it out. Let's run it and it gives us the correct answer. So this is a pass guys. Let's move on to the level 2 of the coding section. Absolutely fast. So let's copy it and let's see. So immediately I don't see any kind of errors. Let's run it. Wow, it's absolutely awesome guys. It is able to generate a snake game, and as you can see all kind of tasks are working. So this is a very good, given it is a very small model. So let's move on to an even harder question now. Now let's see if the model is able to code this or not. Write a snake game in Python using pyqt5. Let's see. So blazing fast, it gives us the code in an instant. So let's see if it's able to get this done or not. So immediately we don't see any kind of errors, which is very nice in my opinion. Let's run this and look at this guys, it absolutely runs. I mean the 3.5, this 3.1 model is absolutely amazing when it comes to coding. Given its coding capabilities, it's gonna be very helpful in many coding tasks. Absolutely awesome. Let's ask something harder. So let's give a follow-up question. It already implemented the scoring model, so we can't have that. So we'll tell it to include a start game interface and a play the game interface and give me the updated code. Let's see if it's able to do that or not. So it gives us the code in an instance. Let's copy the code. Let's paste it. Yo, now actually we see an error. The error is unresolved reference score. So let's try to run it. So it doesn't run, so this is a fail, but let's give it the error and see if it's able to solve it or not. There is a error, unresolved reference score. And check the code for any other and give me code. So let's see if it's able to do it or not. It gives us the code in an instance, and let's see. Yeah, we still have that error, so this is a fail guys. But given this is a 3.18 billion model, absolutely blew my coding test. My coding test originally has 2 or only 3 levels, but it passed all of them, and we went off the chart to get something done difficult with this model. So this is very promising guys, and this model will be actually useful in coding. So I'm very much impressed. Let's move on to the next section, that is the sentence understanding. Let's see how it performs in that. Okay guys, so let's move on to the next section, that is the code sentence understanding, and here we don't have any kind of levels. So let's move on to the first question. The question is write a meaningful sentence where each word starts with the next alphabet. Start from A and end the sentence in Z. So let's see if the model is able to get this right or not. Okay, so let's see A, B, C, D, E, F, G, M, N, O, P, Q, X, Y, Z. Okay, here you can see the model didn't get the T alphabet right, so this is a fail guys, unfortunately. Let's move on to the next question. So the next question is give me 10 sentences that end with the word mango. It is quite hard for small models like this, but anyhow, let's see. Okay, we have got the 10 sentences, and right away we can see the second sentence, the third, the fourth, the sixth, seventh, eighth. Most of them don't end with the word mango, so this is a fail. So now let's move on to an even harder question. The question is, how many words are in your response to this prompt? No model gets this right. So let's see if it's able to get this right, but we know the answer. It's not gonna be able to do it. The answer is 13 words, 1 2 3 4 5 6. So it's wrong. So let's move on to the final question, which is a needle in a haystack test. Let's see how it performs. Okay guys, so this is the needle in a haystack test. So here I have pasted a very big passage and I have inserted 3 words, that is I, love and you. At the end I have asked, there are 3 words in this passage that don't belong to the passage on the place they are in. They together form a sentence with a meaning. Find those 3 words and from them form sentence. Many model gets this wrong. I think maybe apart from the sonnet model. So let's see if it's able to get this right or not, because the LLaMA models actually promise to have good context understanding. So we'll switch to the instant model and let's run it. So the 3 words it says is that love, you and economy. So it's not the right answer. This is a fail, guys. So we are done with the Claude 3.1 8 billion model. We'll move to the next, that is 70 billion versatile model. Let's see how it performs. Okay guys, we are now with the 70 billion versatile model. One thing that you might have noticed is that in all of the previous 8 billion model, the token speed was 750 tokens per second in the grok. Let's see what we get from this model. So let's load up our first question. I will not be explaining the tests as I've already did it, so that we can save some time. Let's move on to the first question. Yeah, we are with our first question. So let's see the murderer question. Let's see if it's able to get the right answer. Yeah, the speed is 250 tokens per second, significantly less, and the model is also significantly larger, so it's quite logical. Let's see the answer. The answer is third room, the one with the lions that haven't eaten in 6 months. The reason being that they are likely to be dead or very weak, making it the safest option. So this is a pass. Let's move on to the next question. Here's the pilot question. So let's see if it's able to guess the name. Again we have 250 tokens per second, and at the end we have the answer. However, I must point out the question doesn't provide any information about the pilot's name. The question only asks about the number of passengers boarding and getting off at each airport, but it doesn't mention the pilot's name. So I'm afraid I don't have enough information to provide a correct answer to this question. So I think this is something with their architecture, I guess. Even this model is not able to understand the intent behind the question, but all other models, given its Gemma model or the Anthropic or the Claude, the ChatGPT family of models, they understand this question. So this is a fail even for the 70 billion version. Let's move on to the max section and let's check for all the 3 questions. Yeah, I've loaded up the first question. This is very simple, so straight away let's run it, and it gets the correct answer 23. It is a pass. Let's move on to the next question. Okay, we have the level 2 max question where it has to use BODMAS or PEDMAS. Let's see if it's able to do it or not. Yeah, it correctly identifies it has to use PEDMAS and it gets the right answer. So let's move on to the final level, which the previous model actually failed. It is the leap year question. So let's see if it's able to get this right or not. By the way, answer is Sunday. Okay, it took significantly longer and it gets the right answer. It is a Sunday. Very nice. So it gets all the 3 levels correct and it comes to this question. Very nice. So let's move on to the coding section and let's see how it performs. It should perform nice because the 8 billion absolutely blew my mind when it comes to coding. So let's see how this model performs. So this is the level 1 coding question that I've given to this model. So it gives us 2 different versions of the code. So both are correct and let's test them out. Okay, so I've loaded up the code and let's run it. So it runs it. So also check the second code as well. Let's run it. Yeah, and it gives us the output. So level 1 coding question, it absolutely passes, giving us 2 different codes. Very nice. Let's move on to the level 2. Yeah, so the level 2 coding question is write a snake game in Python using Pygame. So the previous model was able to do it. This model should also be able to do it, given it's a significantly larger compared to the 8 billion model. So we are getting the code. Let's copy it and let's see how it looks. Immediately we don't see any errors. Very nice. Let's run it. Yeah, and it works as expected. But I think there is something that I actually missed. Let me just end this and try once more. Let's run this code. Okay, here you can see it actually gives me 3 scores even before I started playing the game. This is something a minor error in my opinion, so we can neglect that. Rest of the things in the code is working. Yeah, it's nice. So let's ask even harder coding question. As you know, the question is writing the snake game in Python using PyQt5. Let's see. Okay, so it has given us the code. Let's clear the previous one, paste it. Immediately we don't see any kind of errors. Let's run it, and it absolutely runs. But the score should have appeared at the top, but it appears at the middle. So this is having some kind of these issues, but I think we can neglect that. Okay, and the one more thing that is nice in this is that the game is restarting if we lose. This is something which is nice. Okay, now let's ask it the question which the previous model failed. So that is name in Python like 5. If it had triangular head, start game interface, and play the game interface. It is giving us the code. Absolutely awesome. Let's copy it and try to run it. And absolutely nice. We immediately don't see any kind of errors. So let's run it. Okay, it asks us to start the game, and it says game over, your score is 0. Play again. Okay, so we don't get to play the game. Very bad in my opinion. So this unfortunately was slightly better, but it is a fail. Let's move on to the sentence understanding section and let's see how it performs. Okay, this is the first question as we had it, having sentences from A and Z with each alphabet. Let's run it. So let's see A, B, C, D, E, F, G, J, K, L, M. So now actually this model passes, but here it is using double use, which is adding something which is not right. So I'm still gonna give it a pass, but this should make you understand that in these kind of challenges these two models were not good, but we have to see the 405 billion model to actually come into a conclusion. Let's move on to the next question. Yeah, so the next question is give me 10 sentences with that end with the word mango. Select the versatile model. Let's run it. Okay, let's see. First, second, third, fourth, fifth, sixth, seventh, eighth, 10th. So all the 10 sentences we get it right. So let's ask it a harder question. Give me 50 sentences that end with the word mango. Let's see. So absolutely awesome, guys. The previous model couldn't even get majority of the sentences right, but the 70 billion model absolutely nails this test. All the 50 sentences end with the word mango. This is absolutely phenomenal. So let's move on to the next question. So you guys know this is something which is hard for these models to get right, but let us run this code. In my last message there were approximately 10 words. I have rounded the result to the nearest 10. 2, 3, 4, 5, and 10. Yeah, it has counted the number of words in the prompt right, but I don't think it has got it right when it comes to the response. So this is a fail, guys. Let's move on to the needle in a haystack test and let's see if it's able to get it right or not. So I've pasted the needle in a haystack test. Let's see if it's able to find the 3 words. Okay, it absolutely nailed it. And it says after carefully reading the passage, it has found the 3 words I love and you and formed the sentence. This is a pass. Very nice. Now finally we'll move to the state of the art model from the meta, that is 405 billion. And as it is named reasoning, we'll start from the reasoning section. Okay, I've pasted the murder question, and if you talk about the speed, we had 750 tokens, then we moved to 250 tokens, and let's see how much speed are we gonna get with this 405 billion model. So let's run it. So I tried multiple times, but this model is experiencing very high demand, so we are not able to use the model here in the grok, but we actually don't have to. If we head over to meta.ai, here actually the 405 billion model is hosted. So if you haven't used meta AI, here you can have conversation and also generate images. So it is not something of our concern now. Let's have a new conversation, and here we will be testing it out. So I've pasted my first question. The question, as you know, is the murderous question. Let's see if the model is able to get this right or not. So it gets it right. It says that the lions are likely to be weak or even dead. So this is the safest room. So let's move on to the level 2 reasoning question. Let's see how it performs. This is the pilot question, level 2 reasoning question. Let's see if it's able to do it or not. And here you can see this is what happens when the model gets it right. Both the models didn't understand the question, but this model gets it right. It says the pilot's name is not specified in the scenario. I am the pilot and I can introduce myself if you would like. My name is Captain Meta and I am here to ensure a safe and smooth journey for all my passengers. Now let me calculate the number of passengers I have on board after all the boarding and deboarding. Now it also gets the correct passenger, that is 11, and this is absolutely phenomenal, and this is the best answer that I've heard for this question. I'm absolutely impressed. Absolutely phenomenal. Let's move on to a harder reasoning question that I think we should ask this model. That is giving the level 1 and level 2 reasoning questions together. So I've pasted the two questions and I have not given any kind of explanation. Let's see if it's able to get the answer of these two questions or not. And it gets both the questions right. It says you are a pilot flying a plane, and also it should the murderer should choose the third room. Very nice. Absolutely phenomenal. Let's move on to the max section. Okay, we'll be fastly going over through the first two levels, which it should be getting right. So this is the most simplest question, and even for that it is using PEDMAS. Okay, no issues, and it gets the correct answer 23. So let's move on to the next max question. Okay, this is the level 2 max question. It should get it right, we know that, but still let's ask it, and it gets the correct answer -60.54. So let's ask the third max question, which the 70 billion model was able to get right. This is the leap year question. Let's send it. So it is calculating all the steps and it gets it as Saturday. Okay, this is actually wrong. So I was not expecting this. Let's try this once again. Now it gets it as Monday. Oh no. The 70 billion model got it right, but the 405 billion didn't. Anyways, we'll have to give this a fail. Let's move on to the coding section now. Yeah, the first question, write a Python code to output numbers 1 to 100. It's gonna be easy for them. Give us the code and which is right. Let's paste it and run it, and it runs. Let's move on to the level 2 section. So write a snake game in Python using Pygame. The inference is a bit slow if you ask me. Okay, it has generated the game. Let's see. Immediately we don't see any kind of errors. Let's run it, and it absolutely works. Let's do a self-solution and it ends. Nice. Okay, even harder question, write a snake game in Python using PyQt5. Let's see. It should be running nice, no kind of errors. Okay, let's run it. It runs absolutely well. Let's do a collision. Okay, so this is a pass. Now let's continue the question and ask it. Head to the snake, include a start game interface, play again. Let's see. The previous model got it halfway through, but going by that route, this model should be able to do it, maybe. Let's see. Let's copy the code. Fingers crossed. Let's see. Immediately we don't see any kind of errors. Let's run it. And okay, it couldn't run it. I mean, we just see a blank screen. Okay, this is a fail for this. So even this couldn't do it. And the 70 billion model actually performed better, if you ask me. It at least got the start game button and the play again button. So let's move on to the sentence understanding. Let's see how this model performs. Writing meaningful sentences from A to Z. Let's see. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. It's an absolute pass. Let's move on to the next section. The next question. Okay, so the next question. Give me 10 sentences that end with the word mango. Let's see if it's able to get it right. The previous one nailed it. So 1, 2, 3. Okay, so this model gets all the 10 sentences right. So let's check for the 50 sentences. Okay, give me 50 sentences that end with the word mango. Let's run it. Okay, let's see. Absolutely awesome, guys. All the 50 sentences do end with the word of mango. So I just wanted to just check one thing. It passed the test, but try it for 100 sentences, shall we? Just for fun. Let's see how it performs when it comes to 100 sentences. Okay, it says continuing to 100. So we didn't give it, but we know it is a pass. So let's end it at that and move on to the final question, that is needle in a haystack test, which the previous model got it right. So this is the needle in a haystack test. Let's see. Okay, so after careful reading, it has got the 3 words and has formed the sentence, I love you. Very nice. So this ends our comprehensive test of all the 3 models, and this is actually a mixed bag, guys. Some of the conclusions that I have come to is, firstly, the 8 billion model is absolutely phenomenal in coding. I didn't even expect it to get the first code right, that is coding in Pygame, but it was able to even code in PyQt5 given its size. I was actually impressed with the 9 billion Gemma model previously. If you haven't seen that video, you should have a look. Even in the thumbnail I've mentioned it blows the benchmarks, and I thought it might have the throne for a while, but it seems meta is coming fast and strong, and the 8 billion model absolutely blows it. Given the higher models, the 405 billion and the 70 billion, they are good if you ask me, and the response for the pilot question that the 405 billion model gave me, that was very impressive. I have never seen that response even in the Anthropic or the ChatGPT state-of-the-art models. So finally, we have such models which actually are gonna be useful. These are open source models, guys, so we'll have fine-tuned versions of it, coding versions of it, like the DeepSeek coder and other models, which will further improve what is actually already good in these models. It's very good to see that the open source models are keeping up with the top of the line flagship models, and with good fine-tuning they might surpass the 2 best models as well. But by the time Anthropic will have their Opus model, and the much awaited GPT-5 will absolutely blow the benchmark and will make them insufficient, I think. One recent thing that OpenAI has done before releasing GPT-5 is stopping any kind of jailbreaking to work on the models. If you want to have a look, click on this video at the top right corner. See you guys there. Thank you guys for watching.